Okay.
Just kidding.
So today for notes, we are going to be talking about story problems with exponentials. Good news, story problems with exponentials sort of fit that same concept as story problems with quadratics, where it's not this huge, overwhelming umbrella of read something and then come up with 1 out of 500 options for how to write an equation. Okay, today we have a very straightforward equation that we are going to use. Okay, so if we are dealing with exponential growth, okay, that means that we are talking about something growing or something getting larger. Okay, now it can't just be anything that's getting larger. It has to be getting larger in a non-constant rate. Okay, so I'm going to get a job, and my job is going to pay me $1,000 a month. Okay, except that every month I get a $100 increase in pay. Okay, so at the end of the first month, I'll get $100 more. Into the second month, I'll get even $100 more on top of that. Okay, I have another job option that I could consider, and it's going to pay me $600 a month. But every month at the end of the month, I am going to get a 10% increase in pay. Okay, so it's sort of like option B, option A, option B, which job are you going to pick? Okay, well, this sort of depends on some stuff. So if we go with option A, how much are we getting paid the first month? $1,000. How much are we getting paid the second month? $1,100 because we're adding $100. How much are we getting paid the next month? Right, we okay with this? So then $1,300, $1,400, $1,500. I mean, this is looking like a pretty sweet deal, right? It's not going to take you that long and you'll be doubling your pay.
Okay.
Yep.
Do we have 2 weeks left of school?
At the end of this week, yes. Okay, do we agree with this idea? That's what that first statement says. Job 2, how much am I going to get paid the first month? $600. What am I going to get as a pay raise increase the next month? I'm going to get 10%. How am I going to calculate 10% of $600? Corbin? 0.1. I'm going to multiply by 0.1, right? So I'm taking $600 times 10% is a decimal. Okay, so times 0.1. So that gives me plus 60. So this next month I'm going to make 660. How much am I going to make additional the following month?
66.
Okay, so now I'm finding 10% of 660. And I'll make an extra $66. So now I'll make $726. The next month I'll get a pay raise of $72.60, which will give me 798.60. My students are like, this stinks, right? Over here, doesn't this look like a way better deal? Okay, let's keep going. The next month, I'll get $878.46. And I'll get $966.31. 1062.94. 1169.23. compared to where I am over here, right? Let's keep going. Oh, this is really 10, but whatever. Who's saying that plan A looks better? Do you think plan A looks better? I mean, plan A is better right now, right? You'd be making a lot more money.
Which jobs actually did this?
Do what?
I said I wish jobs actually did this.
Gave you a raise every month?
That'd be nice.
What starts to happen as we get further down the list here? Here I got paid an extra $60. Here I'm getting paid almost an extra $700. Okay, right? Because exponential growth, slow, 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 and then it grows like crazy. Okay, so if you're only going to work at your job for a few months, well then yeah, stay over here. But if you're going to stick something out, exponential growth is what pays off in the long run. Okay, so when we're looking at this today, don't be surprised if you're like, whoa, that is way more than I thought. Now, a lot of things that we talk about, I'm going to sort of break it down into more reasonable values that make sense for you. Please understand that everything we look at is not exact. Okay, so our formula for exponential growth is this. Y equals A times 1 plus R to the X. This is what we use when something is growing. Okay, we also see words like appreciate. So this is a new vocab term for most of us. Appreciation means that the value of something that we own is increasing. Our home value increases. Our land that we own increases. Okay, for whatever reason, the price of it is more than what it was before. Okay, in this equation, the A represents the starting value. Okay, and the R is going to be our rate as a percent in decimal form. Ideally, we should all be able to change a percent to a decimal. If you cannot, pull out your calculator. Okay, and I'll show you how you can do it in your calculator. Okay, you can either A, take whatever your percent is and divide it by 100, or B, if you want something like what is 5% as a decimal, you can actually type 5% into your calculator. Okay, you'll type in 5, the second button, and then your open parenthesis equals. Okay, and you'll type in 5% and then hit equals and it will put it as a decimal. Okay. So Jose opens a bank account and puts in $1,200. So he goes to the bank, he deposits $1,200. It earns 4% interest each month. So first of all, a bank account earning 4% interest each month is not going to happen. Okay? However, there are accounts that you can have that earn interest. Normally, those are based on you putting a lot of money in it to start with. Okay, so when you hear like the wealthier you are, the more money you can make, this is exactly why. If you put a lot of money into a bank account, you can literally just live off of the money that it earns. You don't need to have a job, you just live off of the interest of it. We're going to work with more reasonable numbers instead of plugging in like 4,756,000. Okay? So please understand that these numbers aren't realistic on a small scale. Okay? First thing that we want to do is we want to write an equation that will represent this information. So because we know that it is making interest, it's earning money, the value is getting larger. We know we want to use exponential growth. Okay, so we're going to say y equals, and what's our A, or our starting value, going to be in this problem? 1,200. And then in parentheses, 1 plus, okay, so what's 4% in decimal form? 0.04 to the x. Yes, Caitlin?
So is it okay if I just like put the 1 plus and then put 4 there for the second side?
No, it has to be in decimal form. Okay, so this equation is fine. It's just not in its simplest form. Realistically speaking, we would add these two values together. And we would be here. Okay, so that's our equation. We are now going to make a table that will represent the amount in the account for the first 5 months. Okay, so we're going to make a table. We all know what a table is. We've been doing tons of tables. And we want to do our 5 months out. Okay, so what happens if we put this money into an account and we just let it sit there? Okay, so just like anything we've been doing, what do we think we're going to do with our x values? Plug them in. Yes, Corbin?
Did that 1.04 come from that?
Yeah, I just added them together. You wouldn't be wrong, guys, if you wrote this equation on a test. Now, you would be wrong if you don't have the equal sign, because an equation always has the equals in it. I wouldn't count you wrong for this. You just wouldn't see this in multiple choice, right? You'd see that. Okay, so let's start plugging in. So 1, 2, 0, 0, parenthesis 1.04, up caret 1. And what do we get out? 1, 2, 4, 8. Are we okay with that value? What are we going to do next? You're just all already doing it. What are we putting in next? 2, right? We're changing that 1 to a 2. Okay, so now I get out 1297.92. Is it okay that I have a decimal in this? Yes, why is it okay?
Because we're supposed to 7, so it'll put it into
Because
like
money
pennies.
doesn't do that. Or doesn't do without decimals.
Does money do this?
Yes.
Yes. So 2 decimal points is fine. So let's do the next one. Let's put in 3. Okay, so this one gives us 1349.8368.
No.
Can I write down 4 decimal points?
No.
No. So what am I going to have to do?
Round.
Round, how many decimal points?
2.
Why 2?
Unless you're someone that you can only have 2, like.
Right, that's money. Money is 2 decimal points. Our tens and our hundreds. So 1349.84. Now, guys, here's the deal. I want you to round with our normal math rules because we are in math class. Unfortunately, in the real world, the bank is not going to follow any normal math rules. They're just going to pay you whatever is the better option for them. So they'll round up if it's good for them, or they'll round down if it's good for them. If you owe them money and it's 1.001, they'll still make it $1.01. But if they owe you money, they're only going to pay you $1. Because welcome to how the world works. Okay, so now let's do 4. 1403.83 because I rounded. 14, sorry, I shouldn't have wrote this so close to the desk. 98. So if I put $1,200 in this account and I let it sit for 5 months, how much money am I going to make? Well, I'm going to now have $1,459.98, but how much money did I make? Right? $259.98? Just by letting the money sit there. I didn't do anything with it, it just earned interest. Okay, now let's say we're going to let the money sit there for 3 years. Okay, we're going to put the money in, we're just going to not touch it. Now, here is the key with exponential growth. This label here is years, but the interest being earned is per month. Which means we need to make sure we are working with the same type of label. Just like we can't work with like feet and miles and distance equals rate times time. Right? We need this to be the same label. So how many months are in a year? 12. So if it's 3 years, it's going to be 36 months. So we would need to plug in an x value of 36. Okay, so let's see if we plug in an x value of 36 into the original equation that we wrote. Just like we were with the table. Now, right, I could make this table and do 5, do 6, do 7, do 8, do 9, do 10, do 11, do, until I eventually get to 36, but that's just crazy. Because now we know what the equation is, and we can calculate any point in time. Right, so I'm typing into my calculator, 1200, parenthesis 1.04, up caret 36. And I get out 4,924.72. Which means if we let it sit there for 3 years, okay, we're making over $3,000. That's not a bad deal, right? Now, obviously, like I said, you're not going to get 4% interest on this amount of money. Okay, but how many of you heard maybe your parents or someone talk about saving for a college fund or something like that? Okay, it tends to be that they start putting money in early for exactly this reason. Because you start with a small amount and it earns very, very slowly, but eventually we'll get to that upward curve where it starts growing quicker. Okay, so you need to give it enough time to get past that sort of slow phase and into the really big growth.
Is it better if you don't do it?
No. I mean, I think everybody has their own preference of what they want to do with the money that they have available to them. Okay, so flip your paper over. And we're going to talk about buying a house. So what do we think is a reasonable, you want to stay in Westfield, you're going to stay in this area. How much money do you think you're going to need to spend on a house?
$175,000.
How much do you say, Corbin?
$175,000.
Okay, you say 175. I heard 300,000. Somewhere in between there is about the average income. or the average price of a home for Westfield. So let's say we're going to spend about $225,000 on a home. I mean, I don't know about you all, but I don't have $225,000 just like laying around a spare pocket change, right? So what do people do when they buy a home? They take out a loan. Okay? Does someone just give you a free $225,000 and then you just like give them that money back? You say, okay, good, we're all even. Well, you have to qualify for the loan, but what else do you have to pay? Interest. Okay, so right now, I don't know exactly, haven't looked lately. One day maybe I'll show you how to look. I'm guessing interest rates right now are somewhere around 5.5%. We've got a pretty healthy market. I say 5.5%. Sometimes you can get interest rates as low as like 3.9. Sometimes you're looking at an interest rate of like 7 point something. Okay? It is more complicated. We are very simplifying it down. Okay? We're simplifying it down because there's some things with like principal and what goes to the principal and what goes to the interest. We're just going to do nice and simple, okay?
No, we should do it how it is.
You have to make an amortization table, and you definitely aren't ready for that. Okay, so y equals, what's our equation going to be? What's our a value going to be? 225. Okay, what's going to be in our parentheses? 1 plus. How do we do 5.5% as a decimal?
Just divide 5.5 divided by 100.
Sure, so 5.5 divided by 100 is going to give us 0.055. All to the x. Okay? I want you to calculate how much the value of that loan is going to be. Most people have a home loan for 30 years. This is going to be yearly. This rate is going to be yearly, so we're in years. I want you to calculate the value of that loan after 30 years. So you're going to need a calculator. Do 30 years. Flip it over, write this down. Why don't we think it's right? What's wrong with what we're getting?
Because in reality right now,
It's-
money's lower.
It's a big number.
1,121,989.
Okay, so 1121,389.04, and you better bet they're going to count those 4 cents. That's how much you're going to end up actually paying for your $225,000 home.
That's not what I got.
Now, again, that's not what you got.
That's over 20.
Oh, you have to put in your up caret. 30. Because we're doing 30 years. It's a 30-year loan. Okay, now, like I said, this is a very oversimplified thing, and you're probably not actually going to pay $1 million because you're going to pay some off as you're going. So you're probably going to pay about $800,000. That's still crazy though, right, to think about? But this is how interest and exponential growth works. When you sign your mortgage papers, they'll say, beware for the next pay, you're going to see a really, really large number. And that's exactly where it comes from. Are we okay on that? Does that make sense how that works? And how we can use our equation? Okay, let's go back to our notes and let's look at problem number 2. So flip back over and look at the bottom half. Okay, so now we're going to be talking about exponential decay. What does the word decay mean? Sam?
Wear down.
right? It's getting smaller, so this is going to be words like decay, smaller, depreciates. In science, you'll hear about things that are half-life. That's exponential decay. Notice that our equation looks exactly the same. The only thing that's different is that now we have a subtraction sign. Good news is that logically makes sense, right? When it's getting bigger, we use addition. When it's getting smaller, we use subtraction. Okay, so each year, the local country club sponsors a tennis tournament. So we got a tennis tournament going on. Okay, in this tennis tournament, there's going to be 128 participants. Okay, every round, right, they're going to play 2-on-2, or 1-on-1 every round. There's 2 players per court. Someone gets eliminated. So half of the players will leave each time that there's a round. Okay, we want to know how many players remain after 5 rounds. So first thing we're going to do is we're going to write an equation to represent this information. So equation, we need y equals. What's A on this one? 128. Okay, so 1, am I going to use plus or minus?
Minus.
Y minus. Right, they're eliminated, it's getting smaller. So we're going to use minus. Okay, but now I need the percent in decimal form. Do I see a percent anywhere up here?
No.
Do I see a percent up here anywhere? No. Uh-oh. So how am I going to write a percent in decimal form if I don't see a percent?
If you don't. So can I just put 50, 0.50? Or what do you do?
Y 0.50.
Or, I mean, because that's half of 100, but you're trying to find percent.
Half is 50%. So sometimes the percentage isn't going to be obvious, right? If it's a quarter, we would say 25%.
Or are we going to try to do the half of 128 or 100?
Half is half of 100 because it's a percent, and a percent is always out of 100. Okay, so we're going to have 1 minus 0.5 to the x. All right, 1 minus 0.5 is really just 0.5. Okay, so make a table to represent the number of participants in the first 3 rounds. Okay, class, if we start with 128, regardless of the equation, how many players are we going to have left after the first round? 64, because that's half of them. So how many players are we going to have left after the second round?
32.
32. Then how many?
16. Then 8.
Guys, if you plug in these values, you would get the same thing out. The nice thing about the equation is that you don't have to make the entire table to find a specific point in it. Right? If we start with 1,600 players, 1,600, do you want to start counting half to find out how many are left in the 17th round? Well, no. Right? You could just plug in 17. Okay? So that's the nice thing of just finding a specific point. We can just plug it in, and it will tell us that there will be 4 players left.